Okay. Headed to page 676. Reminder, the Bellware quiz is tomorrow. We spent a good 8 to 10 minutes Friday looking over this information. It does not have to be memorized, but it has to be understood. The exponent in the top is referred to as m. We call it m. That is the exponent at the top. The exponent at the bottom is called n. The number in the front, the coefficient at the top, is called a. The coefficient at the bottom is called b. Understanding that is essential to these three different horizontal asymptote situations. When m is less than n, it's y equals 0. When they perfectly equal, you have to know what a and b are. That's your horizontal asymptote. And when m is more than n, there's none at all. So you have to be able to understand what you're looking at there to get through this problem. Any of them, really? All right, so I need to remind you about this idea of multiplicity. So on number 4, the first thing you do is solve the top, set it equal to 0, divide by 3, x squared equals 0. So I have a little note here that it's a touch and turn. We talked about touch and turn back in chapter 5 when we graphed polynomials. This was a graph, and we would solve these, and we would have a dot at 4, we'd have a point at -5, and then for x squared, we'd have a point at 0. But since it was x squared, it would, sometimes I said it would bounce off the x-axis, sometimes I said it would touch and turn. So it's a 4th degree, so we would start up high, move through the points, hit the touch and turn, go down low, and move back through the points. Do you guys remember that back in chapter 5? It's been a while. Whenever x squared results in an ordered pair, you do have that where it'll just touch the axis and turn. So when you solve the top here to get your x-intercept, that is a point, and it's a point where the line will bounce and come down. All right. If you have your own graph paper, go for it. So then you solve the bottom, add 1, square root, you get plus and minus 1, giving you 2 asymptotes up and down. Consistent with what we've been talking about since last Wednesday, and that is you cannot have an undefined fraction. So putting a 1 in here, 1 squared minus 1 is 0. Putting a -1 in here, -1 squared minus 1 is 0. These are the places the graph does not exist. So since x is squared, there's 2 places. If x was to the 4th, maybe there'd be 4 places. So as the exponent gets higher, it opens up possibilities to more asymptotes. Step 3, compare the exponent. This is x squared and this is x squared. M is 2, n is 2. M equals n, so you have to do a over b. A is 3, and b is an invisible 1. So it's 3 over 1. So this dashed line where y equals 3 is because the exponents match and the leading coefficients are 3 and 1. So this is half credit. You're 50% of the way there. Your graph is broken up into 3 portions: the left, the middle, and the right. After that, you go to the table. So let's make a big table. These require the largest number of points out of all the functions. This will be the biggest table for Algebra 2. And every table is different. We need one. I know I can start with the asymptotes, so go ahead and put -1 and 1 right in. We already know those are undefined. And these are the points, or the values for x that are breaking the graph up anyway. Okay, so I need points to the left. -2, -3. We need points in the middle. We already know the intercept is 0, but you need at least 3 points in the middle to get a good visual. On Friday, the asymptotes were at 4 and -4. They were real spread out. So there was like 8 different options. 6 technically. 7, I guess. But these are not real spread out. There's not a whole lot going on in the middle here. We already know 0. We need more points. So we're going to have to use decimals. We're going to do 0.5 and -0.5. You got to have 3 in the middle. Minimum. And then 2. And then 3. So remember, you're plugging it into both places. So we're going to put that up top in x squared and in the bottom x squared. I like to hear your calculators opening up. Perfect timing. So you guys, Alex, all the way back here, you guys are going to do the negative. You plug the negatives in and share with everybody what you get. In the middle, you guys are responsible for the decimals, 0.5 and -0.5. And over here, you guys are going to do the positives. So you guys do +2, +3. And we'll work together to get this graph filled out. Okay, anybody in the middle here finished with -0.5? Let's do this one. Okay, the next ordered pair would be -2, 4. Anybody else get -1 for -0.5? Okay. What about +0.5? -1 again. There's some symmetry here. Not all of them are symmetrical. Like, don't expect to see repeats like this, but we are seeing repeats. +2 over by the windows. Did anybody do +2 yet? Yes, Mariah? 4. Okay, that's what -2 got, so that makes sense. What about 3? Okay, everybody work on 3. Okay, so same answer, 3.375. All right, now let's see if we can get points on here and make it make sense. See if we can do it. Okay, -3, 3.3. Right about here. and then -2, 4. Okay. I love the way this looks. This is perfect. It lines up really well with the dashed lines. I can start near a dashed line, curve through the points, and end near a dashed line. So that's what we're looking for. We want some sort of elevation change. If it stays totally flat, that's kind of a red flag. But as long as one's a little bit higher than the other, you can move along the asymptote. You're good to go. Then in the middle, we have that 0, 0. That should be a touch and turn. Okay, -0.5, -1. And +0.5, -1. So we'll start near a dash line, move up, touch, and turn at the 0, and then move back down. Try to make it look as curvy as possible, not pointy. Is that a parabola in there? You would think if it was a parabola, it would be down 1. Something to consider. Okay. 2, 4. Good. And 3, 3.3. So 3.3 goes less than 4. And again, this is lined up really nicely. So start and stop near dash lines. There it is. You will be asked about domain and range today in your assignment. Not for all of them, but 2 of them, I think. So the domain is all numbers except plus and minus 1, because those are excluded. And the range is probably the most complicated range we've seen all year. So when I look at y's, it starts at 3 and it goes up. So it goes 3 to infinity, not including 3. Then there's a big gap where the y value does not exist between 3 and 0. And then starting at 0, including 0, it goes down to infinity. So it's kind of cool. We got parentheses in one bracket. 3 to infinity, not including 3. 0 to negative infinity, including 0. Interesting domain and range. When you're ready, we're going to look at number 6 that we didn't finish on Friday. And I will be walking around and giving you points for doing it. So you have some time to finish it. This is the table. So maybe you only got 3 or 4 done. You can finish it right now. It's kind of interesting. None of the numbers go over 1. And here's the visual. When I was plotting points for number 6 times, I thought, well, maybe I should just do my axis by 0.1. Like you can't. If you haven't done it yet, you can try it. You can go 0, 0.1, 0.2, 0.3. That's an option. Now I didn't here, because I didn't think you guys would, so I wanted to match yours. But so this is still just 1 and -1. So there's just a slight decrease from -0.3 to -0.6. So you have to kind of be careful to emphasize that decrease so you can connect it correctly. So I'll give you some time to finish that, and then I'll walk around. But whenever you're done number 6, just go ahead and start number 5. You guys are on 5 through 15 odd today.